Just do the dog barks. Okay, tonight we'll carry on with what we were looking at on Tuesday. Okay, so we're going to just start growing it a wee bit. Now, I say there's nothing more complicated. We throw a few more different shapes in, but there's nothing really to build on in that respect. Okay, so a lot of the knowledge we've got already, which is a good thing. Okay, so we'll just grow in that, and we'll keep building up a few more words. Okay, so let's get into it. Okay, any questions from Tuesday? Okay, I've not posted the video yet, so apologies. I just remembered that today. Any questions from Tuesday? If you've looked at anything? No. Superb. Boom, boom, boom. Superb. Okay. So what we were looking at on Tuesday, we were looking at something called chords, okay, and using that to a bunch of different like story type questions. Okay, so they love a wee story, but they were all essentially the same type of question. They were using Pythagoras, rearranging it, manipulating it to find some hidden values, not hidden values, but missing values, things like height, depth, things like that. So they'll put in a wee story, it's up to you just to extract that. What we'll do tonight is just sort of building that again. Okay, so there's a few more things, a few more type questions that can come up with circles, okay, and triangles. Love a circle and a triangle. Okay, so chord, what was really, really important about the chord is that it did not go through the centre of the circle. Okay, when the line goes through the centre of the circle, it's called the diameter. Okay, so the triangles, what the triangles we'll look at tonight. Okay, we'll have one of their sides made up by the line, the diameter. Okay, we'll have one of their sides made up by the line and the diameter. Now, when we draw a triangle from this position, okay, so we draw a line from the end of the diameter to the edge of the circle. Likewise, from the other edge to the same point. Okay, that angle in there is a right angle. Okay, and that doesn't matter where those lines are drawn. Okay, so if I remove those lines, thought that would be a wee bit easier than that. Okay, if I redraw that circle, okay, and I have the diameter, okay, so going through the centre, and I've got two lines coming from that. If I do that, and that, okay, that angle in there is your right angle. Okay, so those lines, as long as they come from either side of the diameter, wherever they meet is going to create a right angle when it's inside that semicircle. Okay, when it's inside that circle. Okay, so that's a really important one. So there's different shapes that we'll draw tonight. We'll sort of pull on that rule. Okay, another rule when we're looking at lines and circles and angles. Okay, when we've got a circle, like so. Okay, we've got straight line. Okay, touching the outside edge like that. Okay, that's called a tangent. Okay, so that type of line is called a tangent. Okay, we'll call that diameter. Okay, so circle, triangles being forward from the diameter. Okay, and then that's a tangent. What the tangent is a straight line that touches the circle at one point. So it's just touching, it's just skimming that circle at that point there. Okay, that one point. Okay, so the lines are intersecting. Now what we can do with the tangent, and the rule that I want to use with that tangent, is if we draw from the centre of that circle, okay, we draw from that centre of that circle, the line straight down, okay, so that will be the radius. Okay. What that does, where it intersects the tangent, is going to create two right angles, one on the left hand side of the line and one on the right hand side of the line. Okay, so that line comes from the centre of the circle straight to intersect the tangent at 90 degrees. The length of that line will be the radius. Okay, so if you see the radius of the circle and that line isn't actually there, but there's a tangent, we know we can take a line from the centre of that circle and cut that tangent at a 90-degree angle. Okay, so we have a 90 degrees at the right hand side and a 90 degrees on the left hand side. Okay, so we're going to start combining a couple of these, put them together. Okay, couple more angle rules, okay, that we'll cover tonight. Okay, more rules and angles we'll cover tonight. Okay, and these are just sort of generic rules. We have horizontal line, so we have some sort of line coming away from it. Okay, that angle in there, just that angle in there. Okay, angle A and angle B. A plus B is going to equal 180 degrees. Okay, so if we've got a horizontal, okay, or a vertical line, we've got an angle coming off it, okay, they're going to add up to 180 degrees. Now, we can have as many angles as we want coming off that horizontal line, okay, so let's say have another angle like that. Okay. A plus B plus C this time gives you your 180 degrees. Okay, so you can see that. That's similar to if we've got a right angle. Okay, so if we cut a right angle, that right angle, so, okay, that's a 90-degree angle in there. We introduce another line coming away from that same point. Okay. We're going to have A plus B equals 90. Again, we can add as many lines in as, okay, we could have 3 angles, 4 angles, okay, but if there's 2 lines that make up a 90-degree angle, all those angles are obviously going to come from that, okay, so that's a pretty good one considering what we've just been looking at, okay, considering we've just been looking at when we can construct triangles or when we construct lines that create 90-degree angles, okay, so you can start seeing where you're starting to pull in this. Okay. Last one, probably won't use tonight. Okay. But as we've got angles meeting form a full rotation. Okay, so you've got sort of 4 right angles there. You've got angle A, B, C, D. Okay. 360. Nope, 360 square. 360 degrees. Okay, so that full rotation is 360 degrees. Okay, so that's what I'm sort of comfortable with that, but that's where they're coming from. Okay, so you've got lots of angles meeting at a specific point, all the way around will be 360 degrees. Okay. Two more things you might not have seen. We've got two lines parallel. Okay, so they are two horizontal lines. If we've got a line cutting through that, okay, there's a couple of rules that we need to be aware of in regards to angles in this. Okay, so parallel lines are sometimes indicated by an arrow being in both, okay, to show that they're parallel, to show that they're sitting in the same sort of plane on that page. Okay, so they're sometimes indicated by wee lines like that. Okay, now the angles you need to be aware of. Okay, it's called the F angles and the Z angles. Okay, so that angle in there and that angle in there will be the same. Okay. That angle in there, let's call that O, call it whatever you want, and that angle in there will be the same. Okay. That angle in there, that angle there will be the same. Okay. Not used. That angle there, that angle there. Okay, so all the angles there are the same colour, are going to be the same angle. Okay, so where we've got two parallel lines, okay, and a line cutting through that, okay, just be aware that's going to happen. Okay.
See if those ones are the same, would the red and the green be the same and the blue and the yellow also be the same?
Yes.
Yeah.
Yeah. Good shout. Cool. Yep, so red and green are going to be the same, blue and yellow are going to be the same in that picture. Okay, so let's just draw another one. To demonstrate that as well. Okay, nope, not that colour. Just draw underneath. Two more parallel lines. Okay. Line intersecting them this time. Okay, there's also a sort of Z angle rule as well. Okay, so if you've got that angle, you're trying to find that angle. Okay, so those two angles there. Okay, you'll sometimes see come up. Okay, so we'll say that's parallel. Okay, so that's your sort of Z rules. So Z angles. Okay. And F angles. But they're the same thing, same shape, same rules. Okay, but you sometimes see them referred to as Z angles and F angles, simply just because of the shape they make. Okay, one looks like a Z, one looks like an F. Okay, so just be aware that the same angles can be taken from two parallel lines if the same line cuts through them. Okay. Last one I want to look at, okay, and it's going to introduce another type of triangle to the party. So, okay, in the isosceles type triangle. Isos. That's definitely not the right spelling. Isosceles. Yeah, Right, here we go, so we get the right spelling. There's no C in it, that's a good start. Isosceles. Close. Triangle. Okay. Let's see if I can draw one of these. Okay. Isosceles triangle. It's going to have two sides the same. Okay. Sometimes indicated by wee lines like that. Okay, it could be a single line, it could be a double line, just to indicate two things the same. Now, my isosceles triangle, why it's important for us tonight, is that angle in there and that angle in there will be the same. Okay. One of the angles will differ. Okay. If all the angles were the same, okay, it'd be equilateral. But an isosceles triangle, you've got an angle up top, and then the two bottom angles are going to be the same. Okay. The length of those sides has to be the same. Now that's important because if we've got, say, a chord and a circle, and we bring down the two radiuses, then we've instantly got an isosceles triangle. Okay, so the isosceles triangle will come up as well. So when we are looking at problems, and the problems are going to have to find different angles at different points, and then find the sort of the missing angle, I suppose, we could use that rule. Okay, when we've got two equal sides, two equal angles. Okay, so keep that note with you. We'll start looking at examples shortly. Okay. Quickly before we do that, I'm going to look at something called SohCahToa rules. Okay, now this might be revision for some of you, it might be new to some of you. Okay, so SohCahToa. Okay, it's trigonometry rules using sine, tan, and cos. Okay, for right angle triangles. Now, very, very importantly, what we're going to look at tonight specifically is for right angle triangles. Okay, so SohCahToa, right angle only. Okay. Now, this doesn't always come up, the SohCahToa stuff, but it's part of the overall curriculum, so you need to be aware of it in case it does. Now, it does come up, it's been in past papers, and you'll see it in some past papers. Okay, what it allows you to do for right angle triangles, if you have one side and an angle, that allows you to work out what the other sides are. Okay, so you don't need two sides. So what we were using on Tuesday there, when we were doing Pythagoras, we had to have two sides, and then we found the missing one. Okay, now sometimes that was the two short sides, sometimes it was hypotenuse and a short side. Okay, but we always had two sides. Okay, what this allows you to do is find an angle from those two sides, or find a missing side from that angle. Okay, so naming sides on a right angle triangle. If I move too quickly and you miss something with SohCahToa and you want a wee refresher, okay. Incidentally, that's the SQA website just for any updates and stuff. There's nothing up. There was maybe an update today, but I didn't see anything come out. Nat 5 tangent SQA. Nat 5, no, Nat 4 bite size has a lot on this type of stuff. In fact, it'd be trigonometry. So Nat 4, there's stuff in angles if you want any refreshers and stuff. Okay. Also stuff in Pythagoras. If you look at trigonometry, that should be the SohCahToa. If you want the trigonometric. Yeah, so that'll give you your SohCahToa. So this, I'm just going to do a wee refresher on SohCahToa, but if you want anything a wee bit more depth or you've missed something, come back into bite size, Nat 4 bite size maths. Okay, and you'll pick that up there. Okay. Hopefully quite comfortable with it. Okay, so naming sides on a triangle. Okay, the hypotenuse is always the hypotenuse. Okay, so the hypotenuse is always opposite the 90-degree. Okay, the hypotenuse is always the longest side on a right angle triangle. Okay, can't get away with it, just deal with it. Alright. Where it becomes a wee bit trickier is the other two sides. Okay, the other two sides, when we name them tonight, depends on which angle we're going to use. Okay, so if we're working with this angle down here, okay, if we're working with that angle down there, we would call the side furthest away from it the opposite, and we'd call the side touching it, okay, the side touching it, it's this side here, touching the angle, call that the adjacent. Okay, so adjacent. Okay, so the adjacent side always touches the angle that you're working with. So the angle that you're putting into the equation, or the angle you're trying to find, has to touch the adjacent side. Okay. The hypotenuse is always the longest, so the hypotenuse will always touch the angle as well. The side that isn't the hypotenuse touching the angle is going to be your adjacent, named the adjacent. Okay. Now, if I put another triangle here, up. Remember, only with right angles this rule applies. Okay, we got another triangle there. Hopefully you can see that, okay. Don't know why it turned it green. Okay, and we're working with that angle, so we're using that angle in the equation. The right angle is always the right angle. The hypotenuse is always the hypotenuse. Okay. What happens at this point is that side becomes the opposite. And the side that's touching it becomes the adjacent. Okay, so that might throw you a wee bit, but okay. So it depends, the opposite and adjacent depends on the angle you're working with and the angle that goes into the equation. Okay, so SohCahToa rules stands for something. Okay, and the way I write it out is a wee reminder as well. So SohCahToa breaks down into sine of the angle, and I'll just use that. That's the Greek letter theta, the circle line through it. Okay, so that's often used for angles, but you can use again anything you want in there. Okay, so sine of theta equals opposite over hypotenuse. K is cos of theta equals adjacent over hypotenuse. And the last one, the toa, is the tan of the angle equals opposite over adjacent. Okay, so SohCahToa. Okay, rules for right angles only. Okay, so my method when I do this, when I know it's a right angle, I know there's a missing side and I've got an angle, okay, I will write out, once I identify what the hypotenuse is, I'll just write out the whole thing. SohCahToa. Okay, and then work out what I need to find. Okay, so if I'm finding the angle, indicate that. Okay, so okay, and then indicate what sides you've got. So if you've got the hypotenuse, give it a wee tick. Okay, there's going to be one missing. So if you've got the opposite, but not the adjacent, okay, then you can rule out that. So it comes down, so when we do an example in 2 seconds, it comes down to which ones we have and which rule we'll use. Okay, so I'll just write that at the start of any question and then just work my way through it. Okay, as a wee reminder for the best one to use. Okay, so wee example in this. A couple of examples we'll go through just for a wee reminder. Just give you an example of each of them. Okay, so right angle triangle, stop being green. Black. Right angle triangle, if we say that angle in there is 48 degrees. Okay, that's your right angle. We get given the hypotenuse, 22 centimeters, and we want to find out what x is. Okay, so find x. Okay, so let's identify what we've got and then work our way through it. Okay, so SohCahToa. See the way I write that with the middle letter of each a wee bit smaller and a wee bit higher up? It just reminds me that it's that small letter divided by the big letter. Okay, so that by being a wee bit higher up, it's just a wee reminder. Okay, do that, not do it. Okay, okay, what have we got? Well, we've got the angle, so I'll tick all the S, C and T. Okay, we've also got the hypotenuse, so tick the H's. Okay, and what do we want to find? We want to find the side that's touching the angle that isn't the hypotenuse. So it's touching the angle, so it's the adjacent. Okay, so we're not going to be using sine because that would allow us to find the opposite. We're not going to use the tan because we're trying to find the adjacent and we don't have the opposite, so we can't use that. Can't use that, so we must have to use K. K is your cos, your angle equals adjacent over your hypotenuse. Substitute in what you know. Cos 48 equals your adjacent. Just use the letter A for, or in fact, use the letter we're given, x over hypotenuse, which is 22. Okay, and it's a case of rearranging it. Okay, to find out what x is. So that 22 would just come across like we'd rearrange any other. Okay, so 22, you don't have to do a multiply sign, but that's what I'm meaning here. So I would usually just write it 22 cos 48 would equal x. Okay, now if you want, you can write 22 multiplied by cos 48 equals x. Okay, they mean the same thing. Now, get comfortable with cos, sine and tan in your calculator. Okay, we use it as another part as well. They're buttons on their own. Okay, so sine, cos and tan are usually 3 buttons in a row. Pretty clear, should be pretty clear to you. Okay, so just going through that then, you can put in 22 multiplied by press cos. Okay, some give a wee bracket, some don't. Okay, it shouldn't matter. Type in 48 and then type in equals, and you should get 14.7. Okay, I'm going to put x on the left hand side. I've taken that to 1 decimal point. Now, the question would usually ask to put it at a certain amount of decimal points or whatever. In fact, you know what? We'll put it to 2. If it doesn't ask, I usually use the rule, put it to 2 decimal points. So let's stick by that. Okay, 14.72. Okay, so get used to using sine, cos, and tan in your calculators. Make sure you're aware of them, know where they are. Okay. Any questions on that one? So I'll go through examples of every single one of them, just so we've got them to hand. Okay, so we're not sort of missing anything out. Okay, there's no point in rushing it. And then we'll find a couple of angles as well. Perfect. Then we'll take a wee break. Right? Okay, so let's have a wee look. Example 2. Okay, 38 degrees. We'll have x as that, and we'll give ourselves 18 millimeters up the top. Okay, right angle, obviously that one. Okay. Find x. SohCahToa. Another thing, you're not given this SohCahToa in the exam paper. Okay, it's not a formula you're given. Okay, so you'd be expected to know sine, cos, and tan. Those formulas that come with right angles. Okay, so find x. What is x to us? Okay, we are using pretty clearly this angle. So x is opposite. So it's not touching that angle, so it's the opposite. Okay, so that's the one we're trying to find. So we're either trying to find opposite here or opposite here. Okay, that already rules out K. We're not going to use K. Okay, so we're trying to find the opposite, so it's either going to be sine or tan. Okay, now what have we got? We've got the angle, so we can tick those. We've got a wee tick behind beside the S and the T. Okay, what's the other side we've got? Well, the hypotenuse is opposite the 90 degrees, so we've not got the hypotenuse. Okay, we've got the adjacent. So that 18 mil is the adjacent. Okay, so give a wee tick beside the A. That rules out, because we've not got the hypotenuse, that rules out sine. So we can't use sine. Okay, the rule we're going to use, tan of the angle, so I'm just using that letter, Greek letter theta again. Okay, equals opposite over adjacent. Okay. Putting in your numbers, 38 equals opposite, which is the missing side, adjacent is 18. Bringing 18 across in the same way we did last time. Okay, so it becomes 18 times tan 38, and that will equal x. Okay, putting that in your calculator, you're obviously using the tan button this time. Okay, so 3 buttons in a row, sine, cos, and tan, using that tan button. So 18 multiplied by tan, the angle of 38. Okay, getting 14, and we'll do it to 2 decimal points, 1406. And it's millimeters the units. Okay, so always remember the units, really importantly.
Daniel, can you just go over that SohCahToa again, please? How you chose tan?
Yeah, of course.
You know where you've got x is opposite the angle?
Yep.
That O over A is the opposite
Over adjacent.
over adjacent.
Sorry,
because you're
yeah,
trying to
just
find
wrote
the
that,
x.
yeah.
Because you're trying to find that. Yeah, okay.
Sorry, yeah. All right. Let's keep it consistent. So it's just opposite over adjacent.
Okay.
Okay. So that opposite, yeah, becomes x. So we can substitute instead of calling it opposite, just that letter x. Okay.
Okay.
So another example. Let's have another example. Just leave it like that. Don't want it like that. Okay. Go 63 degrees for that angle. Okay. We will have 24 on the hypotenuse, and we want to know what that is there. Okay, so that's your right angle. Okay, so okay, go through that process again. So SohCahToa. Okay, what have we got and what do we want to find out? We've got an angle up the top there. Okay, first side I look at is the hypotenuse. Okay, so the hypotenuse is always the longest side and it's always opposite that right angle. Okay, so we've got the hypotenuse, so we can go to our wee SohCahToa and we can put a wee tick beside the h's. Okay, wee tick beside the h's. We've also got the angle. Okay, so got a wee tick, right, sine, cos, tan. Okay, now it's a case of finding out what do we want to work out. Okay, now we want to work out what x is. X is the side across from that angle, the opposite. So x is now the opposite. Okay, remember the adjacent touches it. So the other side that isn't the hypotenuse touching that angle that we're working with is the adjacent. X is opposite that angle, so it's the opposite. So we're not trying to find the adjacent, we're trying to find the opposite. So we're going to use so. Okay, not using that, not using that. So the sine, the angle, opposite over hypotenuse. Okay, putting in what we know. Sine of 63 equals opposite, which is our x. Hypotenuse is our 24. X becomes 24 sine 63. Okay, if you're more comfortable with a wee multiple in there, put the wee multiple sign between them. Okay, and then putting that in your calculator, 24 times sine 63. Okay, it's giving me x equals 21.38. And didn't have units, so let's put units in it. So we're being consistent. All right. So that's your three rules, SohCahToa. Okay, so sine equals opposite over hypotenuse. Cos, the angle equals adjacent over hypotenuse. Toa is tan equals opposite over adjacent. Okay, just another example showing just a different rearranging so we can find the hypotenuse. Okay, and then we'll do 2 examples finding the angle, and then we'll leave SohCahToa to one side. Okay, so just push SohCahToa to one side. We'll have a wee break, I think, and then we'll come back to a bunch of anglist type stuff. Okay, so 3 more examples. In fact, cancel that. What way haven't we done it? No, done it that way. I wanted to flip that around. Right. Let's work it out. This angle on here, 43 degrees. That's your right angle. The X this time. Let's make X the hypotenuse, okay, and then give us, let's just say 19 there. Okay, doesn't matter. Okay, so X is the hypotenuse this time. Okay, so same approach. Find X. SohCahToa. Okay, got the angle. Okay, what else do we have? We've got the side opposite that angle. Okay, so we can tick that off. That rules out cos. Okay, because that doesn't deal with the opposite, so we can rule out cos. Wipe that away. Okay, what are we trying to find? We're trying to find the hypotenuse, the side across from that 90-degree angle. Okay, so we're trying to find the hypotenuse. So we're going to use sine again. Okay, so we're going to use the same thing. Sine theta equals opposite over hypotenuse. Okay. This time we've got sine 43 equals opposite, which is 19 over hypotenuse. Okay, this is a wee bit of a trickier sort of organisation or manipulation or transformation. Okay, that hypotenuse is currently the denominator. Okay, now we want to find the hypotenuse, so we want that on its own on one of the sides. Okay, call that X. Just a little bit. Okay, so we want that on its own on one of the sides, so we need to change that over to the other side and then move sine over. Okay, so we need to move the hypotenuse over to the left hand side, so it's on the top row essentially. Okay, we can't have it on the denominator. So we want to move the hypotenuse first over to the left hand side. So it would be hypotenuse times sine 43 equals 19. Okay, then we want to move that sine. Okay, so just do it baby steps. Move that sine across. 19 over sine 43. Okay, does that make sense what I've just done there? Okay, so if we move that 19 across, okay, what would happen if we at this stage move that 19 across? what we would have sine 43 over 19 equals 1 over hypotenuse, which is just a bit of a riot of a sum. Okay, you want that hypotenuse on the top, that's why we do it that way. So we bring the hypotenuse over to the left hand side, keep 19 where it is, and then when we move sine over, that becomes the division. Okay, that means we've got hypotenuse where we want it. So putting that in your calculator, the hypotenuse is going to be x. Okay, so I'm just going to call it x at this point. You're just going to do it as a normal sum. So you're going to have 19 divided by just putting in sine 43. Okay, you should get 27.86. Don't have any units. Okay, just to stay consistent, I'll just put units in. Okay, meters. Okay, so just make sure you're comfortable with that in your calculator. So nothing different. You can divide by sine 43 and it'll give you just a number. Okay. Okay, everyone comfortable with that and getting 27.86. Nice one. Okay, so next to we're going to find the angle. So we're going to use it and find the angle. Okay, and this is a wee bit trickier in the calculator. We're going to have to press the shift button and then either sine, cos or tan. Above your sine, cos and tan should be sine to the -1, cos to the -1 or tan to the -1. Okay, so that's the buttons we'll be using. So shift, then one of them. So we look. Right angle, 24. That's the number 9. Okay, and we want to find the angle. Okay, so we're still finding x. Still going through SohCahToa, trig rules for right angle triangles. Right, so this time we've got the side opposite the right angle, which we know is the hypotenuse, the longest side. So we can tick that off. So what we want, hypotenuse is there, hypotenuse is there. We can instantly at this point rule out tan, because we know we're not going to use it because we've only got 2 bits of information. Tan, we can't use it because it's not got the hypotenuse in it. Okay, what else do we have? Well, the angle is that bottom right. Okay, side that we've got the data for is opposite that. Okay, so it's not touching it. Yep. Okay, so we can tick the wee O, and that means we can rule out K. Okay, we're trying to find the angle, which comes under that S. Okay, so sine rule again, and I'll use the word x, opposite over hypotenuse. Okay, sine x equals opposite, which is 9 over 24. Okay, and this is the bit that might be tricky. Okay, so what sine x is, sine is actually something, it's actually multiplying x. So when we move that sine across, don't write that, just look at that. Okay, so it's actually sine multiplied by whatever x is, whatever that angle is. So when we move that sine across, it should become a divide. If you remember our index rules, if we'd write sine to the -1, that essentially means that it is a divide. Okay, if we remember our index rules. Okay, so we're moving that sine across. Okay, and we write it like such. We've got x sine to the -1 and put a wee bracket, 9 over 24. Okay, so when we move that sign across, it's essentially we're moving a multiple across, but we write it in that format. So sign to the -1 and then bracket 9 divided by 24. Okay, so putting this in your calculator, you need to be careful. That 9 divided by 24 you want in brackets. So when we go shift sign, you should get sign to the -1 shown in your calculator. Okay, if it doesn't have a bracket after it, some calculators do it automatically. If it doesn't, put a wee bracket in. Okay, there should be bracket buttons, pretty obvious. Okay, and then 9 divided by 24, and then close that bracket. Okay, so 9 divided by 24. Oh, that was not a 24. I'm doing it in two calculators just because one of them's different setup. Okay. Should get x to equal 22.02. Okay. When we're doing angles, we use the wee degrees sign, which is like a wee circle up to the top right. Okay, so remember to put that in to show that we're meaning degrees. Okay, so 22.02. Again, 2 decimal places, unless it asks, do that. Okay. Everyone comfortable with that in their calculator? That sign? No issues there. Right, we'll do one more. And then we'll have a wee break. Right angle. Okay, what have we got this time? This x 19, 12. Okay. Now later on we go into what sine, cos and tan actually means and why we use it and blah blah blah, okay. But in this case it just allows us to work out relationships and triangles. Okay, but I'll explain those terms in a wee bit more detail. Sure you're keen to know. Okay, so find an angle. What have we got? Okay. If we look at where that angle is, we've got one of the sides that's touching it. Okay. Now that side that's touching it isn't along the side on it. Okay. So it's going to be the adjacent. Okay, so we're either going to be working.
Sorry, Daniel, touching what?
The angle.
Touching the angle. Okay, thanks.
Yeah. So the angle that we're working with. So in this case, we've just named x. Okay, so the angle that we're working with, x, is touching that side. So the angle that we're working with always touches either the hypotenuse and the side that we call the adjacent. Okay, so for using this, the side that we call the adjacent, the A in it, will always be the one touching the angle that we're considering. Okay. Got this side that's not touching the angle, okay, and that's always the opposite. Okay. So that rules out cos in this time because we've not got the hypotenuse. Rules out sine again because we've not got the hypotenuse. Okay, so we're going to be using the tan. Okay, so we're going to be using the tan rule. We say tan x equals opposite over the adjacent. Okay. Going through that then, tan x, the opposite, the one opposite the angle that we're considering, is our 19. Our adjacent, the one touching the angle that we're considering, is going to be our 12. X is going to be tan to the negative 1, and then in the brackets 19 divided by 12. Okay, so remember the brackets there. Shift tan should show on your calculator as tan by a wee negative 1. Put the bracket in, 19 divided by 12 equals, now I'm getting 57.72. And then the wee degrees sign up the top there. Okay, everyone seen 57.72? Nice one, superb. Okay, so let's have a wee break. Let's have a look at okay, so in questions in this will be in pack 2, okay, on Moodle. If it works. Let's have a wee look what we've got. Sorry guys, thought I had this open. My god, not a quadratic. Come on, here we go, right, here we go. So that's the stuff we were doing on Tuesday, Pythagoras, some of that. Pythagoras. Here's a wee bit. Right, here we go. What have we got? Missing angles. There was a wee bit of SohCahToa. That's what I was looking for. Right, I'll show you after the break. I thought there was a wee bit of SohCahToa there at the start. I'll find it. It is somewhere. I've forgotten the page. Okay, let's call it. Let's come back together at 7:30. About that, wee 20 minutes. Get yourself a juice, a wee refresher. I don't know the page and the questions, so don't do anything. Just relax. Okay. Back together at 7:30. Cheers, guys. Start recording that. Okay, so what we're looking at, what we're seeing, let's pick up a couple of the names of the lines that we've been sort of introduced to tonight. Okay, so the tangent PQ. Okay, so what's that telling us? The tangent is a line that touches the outside of the circle. Okay, the PQ is the letters that it goes to and from. Okay, so it starts at P, finishes at Q. Okay, so that's all those letters are saying. That's what's joining those 2 points is that line. Okay, so that just gives the tangent a name. Okay, now those letters can be anything, completely random. Okay, touches the circle with centre O. Now, for whatever reason, they like to call the centre of circles O. Origin maybe, don't know. Okay, so centre O. Okay, so indicated on the drawing with that. Okay. Touches the circle, so PQ touches the circle at T. Okay. At that point there, where we've lettered T. Okay, what else have we given in the question? Angle MTP is 77 degrees. Okay, so Sandra's already alluded to it. There's a couple of ways they can indicate what they're referring to with these letters. Okay, so in this case, in the question, they've said the word angle and they've said these three letters MTP. Okay, now we picked up on it when we were looking at last week when we were looking at chords and things. Okay, there was an example there that we did. Okay, essentially the angle MTP starts at M. The angle itself is at T, the middle letter, and then it goes to P. So that's the direction, M, T, P. Okay, and the angle they're considering, the one that is 77 degrees in this case, is this one in here. Okay, that joins those two letters, two lines. Okay, so M to T, then T to P. Okay, so your angle itself will always be that middle letter. So that middle letter in this case is T. Okay, now they also might indicate it. Okay, well, wee symbol. Okay, that I've tried to do there. Now that wee symbol is just like a wee open triangle. Okay, like that. Okay, and that just means angle, and then there'll be three letters after it. In this case, MOT. M again is the point at which you start. You then go to O. That's where your angle will actually be, and then you finish at T. So let's just go into the diagram. Angle MOT. Start at M, go to O, go to T. The middle letter O is where that angle is. So the question A is asking what that angle is in there. Okay, so let's start going through what we know or what we can see. Okay, first step in these type of questions, I'd almost identify radiuses. Okay, so what the type of lines are. So we know that O is the centre of that circle. So the lines coming away from that centre of circle, okay, the centre of the circle, and touches the outside, they're going to be radiuses. Okay, so line MO and line OT, okay, are the same length and they're both radiuses. Now, importantly, they also touch both sides of line MT. Line MT is a chord. Okay, so the type of line we were working with on Tuesday. Okay, so line MT is a chord which is touching, creating that triangle. Okay, now that's an isosceles triangle. So triangle MOT, okay, that's an isosceles triangle. So we picked up on a rule in that, an isosceles triangle earlier. So we'll come back to that, and I think we'll look at that in part B. Okay, what else are we told? I keep looking at my fingers. What else are we told in the question? We're told the angle MTP is 77 degrees. Okay, so let's find that angle. We know where M is. We know where T is. We know where P is. Okay, so it's the middle letter. That angle in there, 77 degrees. Okay. Now we also know another line that's touching there. We know that line OT is touching there. The OT is a radius coming away from the centre of the circle to the outside edge. It's meeting the circle at the same place as the tangent touches. Okay, now the rule we said about that, where the radius touches at the same point as a tangent, it creates two 90-degree angles. Okay, so if we zoom into that, let's change the colour. That angle there is going to be 90 degrees. Okay, and then on the other side, that angle there, that whole angle there is going to be 90 degrees. So what does that allow us to do? That allows us to find this angle in here. So we've been given that 77 degrees. Okay, we've been given that 77 degrees, that's the angle MTP. We now have enough information to find out angle MTO. Okay, so let's just write that out and put words to it. So we've brought a line from O to T, which is a radius, it touches the same place as the tangent, which is P to Q. Okay, that creates 90 degrees. So if I say angle OTP is equal to 90 degrees, is everyone comfortable with me saying that? Okay. We know angle MTP is 77 degrees. That's given in the question. Okay. So that will allow us to find out what angle MTO is. Okay, MTO will just be 90 minus 77, 13 degrees. Okay, so what have we found out? We found out MTO, this angle in here. So we know that this angle in here is 13 degrees. Okay, it completes that 77 plus 13 will be 90, creates that 90 degrees. Okay. Okay, so that's sort of first step. So we're just building up some of the angles, we're getting to the point. Now we've still not answered question A. Question A is asking MOT. Okay, so it's asking MOT. Okay, do we have enough information yet? No. Okay. What else can we figure out now from what the information we've got? Okay, so we've got a radius touching the end of the chord at M. We've got a radius touching the end of the chord at T. We found out the angle MTO. Okay, and we know this triangle here has got two sides of the same length. So that means it's an isosceles triangle. Okay, so
that angle is the same then at the top.
Yep, so that angle up there is 13 degrees. So that angle we can call TMO or OMT, as long as M's in the middle. Okay, so angle TMO is equal to 13 degrees because the triangle is an isosceles. Okay, we can even sketch that on. So depending how much room you've got in the exam paper, you might want to sketch it on. Okay, so 13 degrees there as well. Now, the rule that we know for all triangles, whatever shape, size, right angles, isosceles, equilaterals, obtuse, acute, whatever, all triangles, the three angles add up to 180 degrees. So we've got two angles, and we want to find the third. So angle MOT would equal 180 minus your 13 minus your 13. Okay, so angle MOT would be 180, which is the total degrees for a triangle, minus the 13 degrees that we know both sides. Okay, minus 13 minus 13 will give us 154 degrees. Angle MOT, starting at M, O in the middle, T at the end. MOT 180 minus 13 minus 13, 154 degrees. Okay, so that's us answered question 1 there. Okay. Did anyone not see that? Super. Okay, so question B, or part B. Okay, the radius is 8 centimeters. Calculate the chord MT. Similar to the questions we were doing on Tuesday. Okay, so by that I mean what we can do with this isosceles triangle. If we zoom into it, remember if we take a line down from the centre, we can cut that chord at a 90-degree angle, and we can create a right angle triangle. Okay, so I've just drawn that line on. Okay, so you can draw lines on to create some more angles. Okay, as long as it makes sense. So I've drawn that line on to create that right angle there. Now what have I got? Well, the question tells me that the radius is 8 centimeters. I know line OM is 8 centimeters. Okay, OM is a radius, or MO, whatever you want to call it. Okay, so that line there is 8 centimeters. That line there is the hypotenuse to the right angle triangle that we've just created. What else do we know as part of this triangle? Well, we know the angle in here. Okay, so we've got 13 degrees and we've got the hypotenuse. We want to know the chord length, MT. We've cut that chord in half by taking our radius away from O. Okay, so we can find out what half the chord length is by doing SohCahToa. Okay, so I threw a lot of words at you there. Hopefully you followed that. Okay, so we're going to find half the chord length by doing SohCahToa. So effectively we've created a right angle triangle. Oops. Upside down. What to do there? Mirror. That's fine. Okay, so we've created a right angle triangle, which is the wrong way round. Maybe I'll flip that. There we go. There we go. Is that right? Yeah. Okay, so go there and end. We've got a right angle triangle. Okay. That corner there is our centre of the circle. That corner there is our M. That angle in there is 13. That length of the hypotenuse is 8. Okay, and I'll draw in the right angle there. Okay, what are we trying to figure out? We're trying to figure out half the chord size, so we're trying to find that X. Okay, so x is just equal to half the chord. So we can just use our SohCahToa rules. Okay, we've got the angle. So we can tick this SohCahToa. Okay, what other side do we have? We've got the hypotenuse. Okay, so we've got the hypotenuse. Okay, so we can rule out the tan. So we don't need tan. So that doesn't take into account the hypotenuse. Okay, what's the other side that we've got? That side x. Okay, there. That side x touches that angle that we're referring to. Okay, we're working with this angle in here. That x is the adjacent because it touches that. Okay, so we've got the hypotenuse on one side, and then we've got x on the other. It's touching that. Okay, so it's the adjacent. Okay. So x is the adjacent. That rules out sine. Okay. Just working with that then. Cos of the angle equals adjacent over hypotenuse. Hypotenuse. Putting in what we know, cos of 13 equals adjacent, which we don't have. Okay, which is the letter x. Hypotenuse is 8. Okay. Taking that 8 across, we've got 8 times cos 13 equals x. Putting that in our calculator. Putting that in our calculator. 8 cos 13. 7.79 centimeters. Okay, so let's go back to the bigger diagram and work out, right, what have we just found out here? Okay, so what is that 7.79? Okay, so if we go back up to your main diagram, what have we found out? We've just found out the length from M to here. Okay, so 7.79 centimeters from that position to that position. Okay, now we're wanting the length of the whole chord. What we've just found out is the length of half the chord. Okay, similar to some of the questions we did on Tuesday. The whole chord, simple as twice that length. Okay, so chord MT equals 7.79 times 2. Which is 15.58, and we're working it in centimeters. Okay, so quite a lot going on, quite a lot of moving things about, thinking about it. Okay, we're using 1 or 2 or 3 or 4 rules. Okay, so we're not just using one thing, it's not prescriptive in that respect. Okay, and that's the thing with these questions, you need to take into account more than one rule at one time. Okay, and that's the sort of tricky aspect of it. Now, also with these questions, you might do it differently to another person, but still end up with the same answer. Okay, so you might find one angle first, where another person might use a different rule and find another angle first. As long as you work through it step by step, you'll come to the same sort of conclusion, if that makes sense. All right.
Do you know how many marks these are worth usually?
Yeah, let's figure it out. Probably Where can I find one of these? So we look. Okay, just take a wee sketch of that and we'll just work through it. So this is 2017, paper 1, question 9, Nat 5 maths. It's worth 3 marks. What we're trying to figure out is calculate the size of angle CAB, and they've actually highlighted it. Okay, so they've actually highlighted it in the paper. So C is your point there. A is the middle letter, so that's the angle you'll be working with. And B is your finish point. Okay, so C, start, A is your middle, the angle, B is your finish. Okay. DBE. Okay, so take a wee quick sketch of that or a screenshot, whatever you want. And then let's have a wee look at what we want to do. Okay, so I think this is so that's what I've got there. Okay, so the tangent's a wee bit flatter, but it's the same angles. Okay, so angle DBE is 58 degrees. So I'm going to draw that in. That was actually given to you in the paper, so I'll just draw that in. 58 degrees. Okay. Calculate angle CAB. So I'll just highlight that angle. That's the one we're targeting. Okay, I'll call it X for right now. Okay, so there's a lot going on there. We've got O, we've been told is the centre. We've been told that ABE is a tangent, so we know that that's touching at point B. Okay, is that the same letter? I'll just double check that. Yep. Okay, touching at point B. Okay, and then we've been given nothing else. So where do we want to start? Okay, so this first thing I would start by marking up would be the radiuses. Okay, and that's a good place to start with everything. Highlight what you sort of know and then go from there. So step 1, I would look at identifying the radiuses. Okay, so what do we know as the radius? So O is the centre of the circle and obviously the outside of it. So O to D is a radius. O to C is a radius, and O to B, okay, is a radius. Okay. The radiuses we can use tells us a lot. So CD we can tell is a diameter as well. Okay, and that tells us something. So we'll come back to that. So I would say the second thing I would want to sort of mark up, okay, would be locate right angles created at tangent. Okay, so one of the rules we looked at, that if we've got a radius coming from the centre of the circle, touching at the same place as the tangent is, that's going to create a couple of 90 degrees angles. Okay, so if we zoom in, okay, we've got 58 degrees there. That angle from the radius to the tangent, that's going to be 90 degrees. Okay, so DBE is 58 degrees. We can say that OBE, okay, angle OBE is equal to 90 degrees. Okay, so angle OBE is equal to 90 degrees. That allows us to figure out what angle OBD is. So if we say that OBE is 90, we know that DBE equals 58 because we get given it. You can determine that OBD, if I lose anyone, let me know, so that'd be 32 degrees. Now, see at this point, I'm just going through my rules and I'm just working out a couple of them to try and get to that angle CAB. They're not going to give you something really simple that instantly links to CAB. Okay, but we're getting closer. We've worked out another angle. We've worked out OBD. So we've worked this angle out in here to be 32. Okay. Now I sort of want to work towards CAB. Okay, so can I use the information I now know to work out any of these angles in here? Okay. Now I could take this information and go up to this angle and say that's 32 degrees as well because that's an isosceles triangle. But at this stage, it's not really giving me anything. Okay, so BDO would be 32 degrees. All right, but it's not really helping me towards my cause. Write it on. It doesn't take much time to write it. Okay, just for your awareness, but it doesn't actually help. Okay, so what does help? Okay, if we could figure out what this angle in here is. So we could figure out what OBC, that angle is in there. Okay, that would help. So we're getting towards the angle that we're looking for. Now, OBC, there's a couple of things going on. Okay, these two radiuses and then joining C and B by a chord, that's telling me that that's an isosceles triangle. Okay, I also know that this angle CBD, okay, that's going to be 90 degrees, CBD, because it's a triangle inside a semicircle. Okay, so that CD is a diameter. The two lines that come away from that and meeting at a single point, DB and CB, is going to meet and create a 90-degree angle. Okay, does that make sense? So in here, angle C, let's make it red, CBD, that angle there, I've just drawn on, it's 90 degrees. Maybe a different colour. It's going to be 90 degrees. Okay, so if I come away from that, I could say my step 3 is angle CBD is 90 degrees because it's a right angle triangle inside a semicircle. Okay, that allows me to figure out, well, if angle OBD was 32 degrees, then angle OBD plus CBO is going to be 90 degrees. Okay, so because we know what angle OBD is equal to 32, just work that out. Angle CBO is equal to 90 minus 32, which is equal to 60, 58. Okay, so we've just found out this angle in here. Okay, so we've found out this angle in here. Oh, that's interesting. Okay. Now, because this is isosceles, that angle and that angle must be the same. Okay, so we can draw in that OCB. OCB is 58 degrees. Okay, so we're getting closer. Not quite there yet, but we're getting closer. And what can we do with these two things? A few bits going on. So if we go back down to this corner, okay, we know that's 58 degrees. We also know that OBA is going to be 90. So that angle in here is going to be 90 minus 58. Already done that calculation. That angle in there is going to be 32 degrees. Okay, so we've drawn a couple of things on there, so let's just write these down as we're going through it. Okay, so 4, because triangle BOC is an isosceles, okay, that allows me to say the angle OCB is the same as angle CBO, which is 58 degrees. Okay. The next thing I did was work out angle CBA. Okay. Knowing that OBA is 90 degrees, I could do 90 minus 58 is 32 degrees. Okay, so I missed out a step there. That 90 is angle OBA. Okay, and that's created with the radius hitting the tangent. Okay, so what have we got? We've got this angle in here, we've got an angle up here, but I'm missing two other ones. Okay, I'm missing this angle here, and I'm missing this angle here. Okay. What's not obvious, although it is pretty obvious actually, just by looking at that you can tell that's not an isosceles. So you can tell line AC is not the same length as CB. So that's telling me that angle CBA and angle CAB is not going to be the same. Okay, so it's not an isosceles, so it's not going to be the same. So I know that immediately. Okay, so that's a good thing to know. What I then need to find out then, okay, what I need to find out then is another angle in this triangle. Okay, so I want to find this angle, I find out this one, I want to find this angle here. Okay, so angle ACB, I want to find this angle in here. Okay, so what rule can I use to figure out that angle in there? Well, I know that's 58 degrees. I know that that line OCA is a straight line, horizontal line. Okay, so that 58 degrees plus this angle here is going to equal 180.
So do you call that angle ACB 122? Or ACD?
ACB. ACB.
ACB.
So let's call that 6. Angle ACB will equal 180 minus that 58, which is going to be 122. Okay, so that angle in here, 122 degrees. That leaves us only with one angle missing in that triangle. Okay, so we've got 32 degrees here, 122 here. The missing one is the one we're actually wanting. We know the rule that all the angles in a triangle equals 180. Okay, so whatever triangle, whatever type of triangle you've got, 3 angles equal 180. Step 7. Okay, angle CAB, which is the one we want, is equal to 180 minus the 122 we just found out, minus 32. Okay. Which is 26. So a lot going on. One step at a time, one angle at a time. Build up the picture. If you can't find one angle, move to another one, see if you can find that. Start making links, start making connections. Okay. So angle CAB, which is what the question asked for, that one here, we found by finding the 2 other angles in that triangle. Okay. Now there might be another way to do that. There might have been a different way. I don't think there would have been a lot quicker way. Okay, that I can see. But there was 4 or 5 different rules we had to use there. There was rules of isosceles, there was where the tangent met. Okay. There was that right angle triangle within the semicircle. Okay, so there was 4 or 5 different rules that we've talked about tonight used in that one question, only getting you 3 marks. I think that's quite stingy. Okay, only getting you 3 marks. Okay, so what I'm going to do, so that's 20 past.
Are you likely to leave the best thing to, if you see that on the paper, leave that till last? Because if you're only getting 3 marks, you're not going to waste a hell of a lot of time on that, are you?
Yeah, you could think strategically like that. But once with a wee bit of practice, you start. I would start sketching that pretty quickly. So I would see, like, I paused quite a lot there, but I would see pretty quickly that OB was a radius that had a tangent. That angle in there is 90, 90 minus 58. I could sketch in there 32 pretty quick. Okay. Likewise, okay, there's a triangle there that is coming out to me that's coming from a diameter, so that's a right angle in there as well. So you start picking up stuff very, very quickly. okay, and start throwing it out. I was going to say we could work in a wee breakout room, but those two are quite difficult. Let's have a wee think. So this is 5 marks. So 2015, question 3, paper 1. So non-calculator again. AC is a tangent, centre O, contact B. 77. DEF, 64, so you're given that. Calculate BDF. BDF. Okay, I'm going to put you in a breakout room. And I'll break you up. So there's 12 people, so I'll do groups of 4. Okay, and talk about what you're seeing here. Okay, and try use the rules that we've noted down at the start to start picking off the angles. Okay, so you're probably picking up a couple already. We're looking to find BDF. Okay, so start picking off what you can. So I'm going to put us in breakout rooms. Okay, groups of 4.